Catastrophic disturbances in urban forests. Hurricanes play a significant role in shaping the forest ecosystems in Atlantic Canada as they cause major changes to forest structure. Urban forests, such as Point Pleasant Park, are especially vulnerable to catastrophic disturbances such as hurricanes. They reshape the entire forest landscape as they can remove large amounts of tree canopies at one time. This disturbs the entire ecosystem, leading it into a period of succession and regeneration. Point Pleasant Park is an urban forest located on the eastern end of Halifax and is approximately 185 acres in size. Up until the year 2003, the forest primarily consisted of long-lived tree species such as red spruce, white pine, red maple, balsam fir, and white birch. The area of Point Pleasant Park lies on Mi'kmaq territory in a village called Tukati, meaning spirit place in English. This area was protected by the Mi'kmaq peoples as they would gather at Tukati for the first 7 days of the first moon during what is known as Skuluku, or the frog croaking mouth. Point Pleasant Park after Hurricane Juan. On September 29th of 2003, Hurricane Juan, a Category 2 hurricane, hit Halifax. As a result, over 300,000 homes and businesses lost power, and the forest community of Point Pleasant Park was severely impacted. Losing 70% of its trees, it was left almost unrecognizable. The damage was so severe that the park was closed to visitors for 8 months in an effort to clean up the fallen trees. Since 2004, Point Pleasant Park has been in secondary succession. Secondary succession is a form of succession that occurs on sites after experiencing a disturbance, such as a hurricane, but previously supported life. In the discussion portion of this presentation, we will expand on the specific ways the succession has impacted Point Pleasant Park between 2004 and 2024 by displaying data that has been carefully collected from the forest between this time span. Our general objective is to provide a clear understanding of what succession is and how it has occurred in Point Pleasant Park between the years of 2004 and 2024. The null hypothesis is that there has been no change in the urban forests of Point Pleasant Park between these years. And the alternative hypothesis is that there has been a significant change in the urban forests of Point Pleasant Park between 2004 and 2024.
To collect data, 6 different sites in Point Pleasant Park were chosen to be studied once every year from 2004 to 2024 in the fall. These specific sites were chosen because they were in places most impacted by Hurricane Juan, with lots of trees lost from being uprooted from the soil. Each site was in a 20 meters by 20 meters area. In each site, trees and ground flora were identified and counted. To count the trees, every tree that was longer than 2.5 centimeters in diameter at breast height was identified to their species using a field guide or iNaturalist and counted. Quadrant sampling was used to count ground flora. A bright object was thrown into the site, and a 1 by 1 meter quadrant was placed around its landing spot. In this quadrant, all species were identified and the percent cover of the quadrant estimated. This step was repeated 12 times in each site. Using the estimated percent cover and tally of species, the density per tree species in each site was calculated, along with the density of 2 specific species, the red maple and red spruce, and the species richness and species diversity were calculated. To analyze the relationship between the year and every variable calculated, simple linear regression was used. This method was chosen because we wanted to test for a possible significant relationship between the change in years after Hurricane Juan and change in each variable.
The first discussion question of this experiment is, how has the overall forest community changed over time? Why? What can you predict will happen to the overall community as the forest moves towards its climax community? Why? The null hypothesis states that there has been no significant change in diversity or growth in the urban forest of Point Pleasant Park between the years of 2004 and 2024. The alternative hypothesis states that between the years of 2004 and 2024, the overall forest community in Point Pleasant Park has diversified significantly. This experiment was performed to examine the effects of Hurricane Juan on the urban forest of Point Pleasant Park over the years. From the year 2004 to year 2024, the Shannon Diversity Index has been plotted as a linear regression, and the average Shannon diversity values are shown with a line of best fit, providing a good visual as to how the forest is changing over time. It is noted that the years 2005, 2007, and 2016 are not included in the dataset because hurricanes occurred in these years, and 2020 is not included due to the COVID-19 pandemic. The linear regression equation is equal to Shannon diversity equals 0.0606x minus 120.85 and has a positive slope, indicating a constant increase in Shannon diversity over the years. The R-squared value is approximately 0.34, and in the first degree of freedom, the p-value is 2.3 times 10 to the power of negative 8, which further statistically supports the alternative hypothesis. The null hypothesis has been rejected. The secondary succession that was initiated after the hurricane hit in 2004 caused an increase in diversity between the years of 2004 and 2024. It is predicted that the increasing trend in diversity will continue in this manner until the forest reaches its stable climax community. As seen in this linear regression graph, the average Shannon diversity index in 2004 is approximately 0.5, and in 2024 it is just under 2, showing a clear increase in forest diversity over the time since Hurricane Juan.
The next discussion question of this experiment is, how has the density of the dominant species in 2004 as well as the dominant species in 2023 changed over time, and why? What can you predict will happen to the dominant species as the forest moves towards the climax community, and why? The null hypothesis is that there is no significant change in the density of red spruce in Point Pleasant Park from 2004 to 2023, while the alternate states that there is a significant increase in the density of red spruce in Point Pleasant Park from the given time period. A linear regression analysis was performed to evaluate the relationship between time and the density of red spruce in Point Pleasant Park to determine whether there has been a significant change over time. The linear regression equation was RS, or red spruce, equals 0.34y subtract 685.5, indicating a positive relationship where red spruce density increases by approximately 0.34 trees per 400 meters squared for each additional year. The F statistic was 11.8 and the p-value was 0.0009, indicating that a statistically significant relationship had occurred. Therefore, we reject the null hypothesis, concluding that there is a significant increase in red spruce density over time. Another species to look at is the red maple. Similarly to the red spruce, the null hypothesis for the red maple is that there is no change in the density of red maple in Point Pleasant Park from 2004 to 2023, and the alternate states that there is a significant increase in the density of red maple during this time. A linear regression analysis was also conducted here to assess the relationship between time and the density of red maple in Point Pleasant Park. This was to identify any changes over the given time period. The obtained linear regression equation was Rm, or red maple, equals 2.57y subtract 5,140.7, showing a positive correlation and indicating that the red maple density increases by 2.57 trees per 400 meters square for each following year. With the F statistic of 16.8 and a p-value of 0.0002, the analysis indicates a significant relationship. Therefore, we reject the null hypothesis and conclude that there has been a significant increase in red maple density over time. The data for both red spruce and the red maple show a clear increase in the density of dominant species between 2004 and 2023, represented by positive slopes in both graphs. This trend suggests that the dominant species have not only survived but thrived over time, likely due to their competitive advantage in acquiring essential resources such as sunlight, water, and soil nutrients, and their resilience after facing storms such as hurricanes. As the forest continues to mature and move towards a climax community, the dominant species may begin to face more intense competition for resources. This competition could lead to the stabilization in their density or even a slight decline. Although we see a decline of density following the years where major hurricanes have occurred, red spruce and red maple are both known for being resilient to natural disasters, specifically strong winds. Red maple has the ability to regenerate quickly by a process known as stump sprouting, and red spruce have strong root systems that anchor them into the soil. Thus, while the dominant species have flourished up until this point, future trends may see a more diverse ecosystem as the forest reaches an equilibrium.
To identify the effect of secondary succession on species richness in Point Pleasant Park after Hurricane Juan, simple linear regression was used to determine the relationship between species richness in Point Pleasant Park and time passed. There was a significant positive relationship between species richness in years after Hurricane Juan, with a R-squared value of 0.6051. Therefore, our hypothesis is not rejected. From 2004 to 2024, the species richness in Point Pleasant Park increased greatly, and now there is a greater amount of around 10 different species in each site. The increase was largest from 2004 to 2015, as that was when the forest was the most barren and free for different species to settle in. The low amount of species richness in 2004 is due to the loss of 70% of tree species from the destruction of Hurricane Juan. The reason richness had increased over time after being reduced to almost zero is due to secondary succession. According to Malls and Cahill, the area that the uprooted trees had occupied was now empty and just soil, which means that this area is now free for new flora to enter and spread out. Initially, this area would be occupied by species less affected by Hurricane Juan, and more new species would come to occupy this area because of the abundance of unoccupied space. From 2017 to 2024, the species richness seems to stay at a number of 10 to 14 in each site, which could indicate that these species are approaching the climax community. As it approaches the climax community, I would expect the species richness to stabilize even more and become more consistent each year after 2024.
Based on the topics covered in this slideshow and the observed data, Point Pleasant Park is currently in the mid-successional stage due to multiple factors, the main influence being the catastrophic Hurricane Juan that hit Atlantic Canada in 2003. Since this event, the forest has been steadily regenerating with more rapid growth the first few years following the disruption. Red maples are a good indicator for showing that the forest is in its mid-successional stage, as they are generally classified as mid-successional species. In relation to urban parks in succession, urban parks are often looked at by the individual rather than as a whole. Although focusing on an individual has benefits, including energy conservation, aesthetic, and recreation, treating the urban park as an ecosystem can also benefit biodiversity, reduce water runoff, and reduce erosion. Being an urban park can significantly affect succession due to habitat fragmentation. Urban parks are often isolated areas of green space surrounded by urban infrastructure, limiting the movement and dispersal of plants and animal species. Two-eyed seeing was a concept introduced by Mi'kmaq elder Albert Marshall, and it means learning to see from one eye with the strength of indigenous knowledge and from the other eye with the strengths of Western science. Traditional Mi'kmaq knowledge often emphasizes the importance of natural indicators, mainly for observing native species or invasive species. If we choose to observe the forest's health as a whole, by assisting in the production of native species and the removal of invasive species, we will ultimately bring with it increased biodiversity, cultural relevance, and sustainable forest management. We would like to thank everyone who participated in this lab, including Professor Allison Schmidt, who played an integral role in all aspects, as well as many students across the years who assisted with the data collection. And lastly, we would like to thank each other within our group for everyone's hard work and dedication.